Right, so 9.2 and 9.3 are together. 9.2 deals with arithmetic sequences, and 9.3 is geometric sequence. So an arithmetic is when we add to get from one term to the next one. Geometric is when we multiply. So they're kind of similar in the process of what we're doing, but one of them's adding and one's multiplying, so each sequence has a different formula that goes with it. So in an arithmetic sequence, we have this formula here. So a sub n is equal to a, which a is our first term, so the first term in our sequence, plus n, which is the number of term that we're looking for, and d, which is the common difference. So the common difference is what we add to get from one number to the next. So this is our formula. We could find whatever term we want in our sequence just by using this formula. All right, so on the next slide, in examples 3 through 6, we have to tell whether the sequence is arithmetic and explain our reasoning. So arithmetic means that we add to get from one number to the next. So what am I adding to get from 1 to negative 1?
Minus 2.
Minus 2, so I'm adding a negative 2. And then we just have to make sure that we do the same thing each time. So if I add negative 2 to get from 1 to negative 3, does that make sense? I can subtract 2 again. What's negative 1 minus 2? Negative 3, so it makes sense there. What's negative 3 minus 2? Negative 5, and negative 5 minus 2? Negative 7. So since I have a common difference for each term, they're all the same, this would be arithmetic. And my common difference, which is d, would be negative 2. So that's what I'm adding to get from one number to the next. For number 4, what am I adding to get from 12 to 6? Negative 6. If I subtract 6 again, do I get 0? Yep. If I subtract 6 again, do I get negative 6? If I subtract 6 again, do I get negative 12? So would this be arithmetic? Yeah. And what would my common difference be? Negative 6. All right, for number 5, what do I add to get from 5 to 8? I add 3. If I add 3 again, do I get 13? No. So since I'm not adding the same number each time, this would not be arithmetic. So we could just say no. You could say not arithmetic. So since we don't have a common difference here, it's not arithmetic. All right, for number 6, what do I add to get from 3 to 5? Add 2. And if I add 2 again, do I get 9? Nope, I would have to add 4, so they're not the same. So is this arithmetic? Nope, not arithmetic. All right, example 1, we have to find the 10th term of the arithmetic sequence. So here we're going to use our formula. We have a sub n is equal to a plus n minus 1 times d. So a is our first term, n is the number of term that we're looking for, and d is our common difference. So here it tells me I'm looking for the nth term, so that would be a sub 10. It says 10th term here. What is my first term in the sequence? 2. So that would go in the first spot. Then plus n minus 1 would come next. What is the number of term that I'm looking for? 10. So n would be 10. So it'd be 10 minus 1 in the parentheses. And then what's my common difference? What am I adding to get from one number to the next? I'm adding 6, and adding 6, and adding 6. So what's d? 6. So then from here, I just have to do the math to solve. So I have a sub 10 is equal to, what do I have to do first? Parentheses. So 10 minus 1 would be 9. What would I have to do next? Multiply. So 9 times 6 is 54. And then 54 plus 2? 56. So our 10th term is 56. So example 2. Again, we're doing the same thing. So my formula is a sub n is equal to a plus n minus 1 times d. So a is our first term, n is the number of term that we're looking for, and d is the common difference. So I'm looking for the 10th term, so I'm trying to find a sub 10. What is my first term? 15. The first term in the sequence is 15. So it's my a. So then I have plus n minus 1. So n is the term that we're looking for. So what term am I looking for? The 10th term. So what would n be? So it'd be 10 minus 1 in the parentheses. And then what's my common difference? 8. I'm adding 8 to get from one number to the next. So d would be 8. And then what should I do first to solve? Parentheses. So 10 minus 1 is 9. And 9 times 8? 72. And 72 plus 15? 87. So a sub 10 is 87. All right, example 3. So example 3 asks us for the 100th term. So again, I have a sub n is equal to a plus n minus 1 times d. So I'm looking for the 100th term now. What is my first term? 6 plus, what's n? 100, because I'm looking for the 100th term. And what is the common difference? What am I adding to get from 6 to 11? I'm adding 5, so common difference would be 5. What do I have to do first to solve this? Parentheses. So 100 minus 1 would be 99. And then 99 times 5? 495. And then 495 plus 6? 501. Awesome. So one way of doing this would just be adding the common difference each time to get the next term, the next term, the next term. You could do that if you only had 10 terms, but if you had 100 terms that you're looking for, you would have to add 6, 100, or you'd have to add 5, 100 times, which would take a long time. So that's why the formula comes in handy. Next, we're going to be looking at geometric sequences. So geometric is when we multiply to get from one number to the next. So our formula is a sub n is equal to a, which again, a is our first term, times r, which is our common ratio. So it's kind of like the common difference, but it's just what we're multiplying each time to get to the next. And then again, n is our number of terms that we're looking for. Number of term. So the first 4 examples we have here is to tell whether the sequence is geometric. And then if it's geometric, we want to find our common ratio. So what do I multiply to get from 96 to 48? So one way that we can find what that common difference is take our second term and divide it by the first. So that would be 96 divided by, second. So it would be 48 divided by 96. So it's the second divided by first. What's 48 divided by 96? So 0.5. It would be 1/2. So I'm multiplying by 1/2 here to get from one number to the next. So if you notice, our numbers are getting smaller. So technically we're dividing, but always for geometric, we're multiplying. So if your numbers are getting smaller, you're just multiplying by a fraction. So let's double check. If I multiply 48 by 1/2, do I get 24? Yep, if I multiply 24 by 1/2, do I get 12? If I multiply 12 by 1/2, do I get 6? Yeah. So is this geometric? Yeah. And what's my common ratio? 1/2. All right, for number 6, we do the same thing. To find what our common ratio is, we would do the second term divided by the first. So we could do 243 divided by 729. If the numbers are really big like they are here, you don't have to do the second divided by the first. You could do like the 5th divided by the 4th. So we could do 9 divided by 27. Do we know what 9 divided by 27 is? 1/3. So I would multiply by 1/3 to get from one number to the next. And then we can check. What's 729 times 1/3? So I checked that. If I go from 27 to 9, I'm multiplying by 1/3. So I want to make sure that it's true for all the numbers. So if I multiply 729 by 1/3, do I get 243? Yeah. If I multiply 243 by 1/3, do I get 81? If I multiply 81 by 1/3, do I get 27? So is this geometric? Yeah. And what would my common ratio be? Common ratio is 1/3. All right, for number 7. What do I multiply to get from 2 to 4? Multiply by 2. If I multiply 4 times 2, do I get 6? So would this be geometric? Nope, it's not geometric. Number 8, we do the same. What do I multiply times 5 to get 20? I multiply 4. If I multiply 20 times 4, do I get 35? So is this geometric? Nope, not geometric. Okay. One way that we can find r, again, is dividing the second term by the first. So I would take 6 and divide it by 3. What's 6 divided by 3? 2. So I would multiply times 2 to get from 3 to 6. You can do that with any two terms here. So if I did 12 divided by 6, what's 12 divided by 6? 2. So again, I would multiply by 2. I could do 24 divided by 12, which is 2, and 48 divided by 12. 48 divided by 24, because you do the one right before. That would be 2 also. All right, in example 4, we have to find the 10th term of the geometric sequence. So our formula for geometric sequences are different than arithmetic. We have a sub n is equal to a times r to the power of n minus 1. So a, again, is our first term. R is our common ratio. And n is the number of term that we're looking for. So here I'm looking for what term? The 10th term. What's my first term in the sequence? 4. What's my common ratio? What am I multiplying to get from 4 to 12? 3. And then what number of term am I looking for? 10. So n would be 10. What do I have to do first here? The exponent. So a sub 10 is equal to 4 times 3. 10 minus 1 is 9. What do I have to do next? 3 to the 9th power. So in our calculator, there's like a little up button in most of them. Depends on what calculator you have. But you would do 3 to the 9th power. So that would be 19,683. And then what's the last step? Multiply times 4. So you should get 78,732. Yes, you can use a calculator. All right, example 5, we're looking for the 7th term of the geometric sequence. So again, my formula is a sub n is equal to a times r to the power of n minus 1. So I'm looking for what term? The seventh term, so a sub 7. What's my first term? 1. What's my common ratio? What am I multiplying to get from one number to the next? I'm multiplying by -3. Perfect. So that would be -3. What is n? N is 7th because it's the 7th term. So 7 minus 1 would go in our exponent. What do I have to do first? The exponent. So 7 minus 1 would be 6. And then what do I do? -3 to the 6th power. So if you're doing that in the calculator, make sure you put -3 in parentheses. So it'd be -3 to the 6th power, which would be 729. And then what's 1 times 729? 729. So you have to put 3 in parentheses, or else it'll think that it's like 3 to the 6th power and then times -1, and it'll give you a negative answer. No. So make sure you put the 3 in parentheses. Another way that you can check to make sure your sign and your answer is right is that we're looking for the 7th term of our sequence. Is 7 an even or odd number? 7 is an odd number. And look at our terms. The first term and the third term of our sequence, are they positive or negative? They're positive. So the odd terms in our sequence are positive. So we know our answer is going to be positive. If it asks for the 8th term, then it would be a negative number because even terms here are negative. So you can always double check your sign that way.